Hi everyone, thank you so much for coming to this lesson. So today we're going to be going through inequalities for AS level maths. So for this lesson, quadratic equations and solving them will be really useful. So if you don't remember that already, please go back to that lesson and then come back. So the learning objectives is to be able to solve linear and quadratic inequalities and interpret these graphically, be able to express solutions using set notation, and be able to represent linear and quadratic inequalities graphically. So like always, there's going to be timestamps in the description to the video, where it's going to be telling you when we'll be doing different examples and when we're going through the different topics. So feel free to skip to any parts you want to. But yeah, let's get into it. So firstly, what is an inequality? So inequality is just when you're trying to compare two different statements or two different equations, and there are different signs that we use when we're describing an inequality. So the first one is just this sign, and that just means less than. So you could have an example of inequality could be like x is less than 5. So you just read that like that. And then if you put, if there's a line under it like that, that just means that x is less than or equal to. So a line like that with no line at the bottom just means less than, but if you see a line underneath, that just means less than or equal to. So I can just write that out again. So that just means less than or equal to. If you had another example, could be like x plus 2 is less than or equal to 5. So yeah. And then the opposite way you could have is this sign, and that just means more than. So you could have something like x is more than 10. And then similarly, if you put a line below, it just means more than or equal to. So if you see anything like that, it's just more than or equal to. So an example could just be like anything, it'd be like x plus 3 is more than or equal to 15. So yeah, an inequality is just comparing the two different ones, two different statements, two different equations or numbers. So the difference between a linear and quadratic inequality is just like the difference between a linear and quadratic equation, like they're really similar. So anything that has an x squared on it in the equation, that would be a quadratic inequality. So you could have something like x squared plus 4x is less than 5. That would be called a quadratic inequality. So yeah, whenever you have x squared in it, just remember quadratic. And then if it's just any of what I've put over here, because there's just an x, they're just a linear inequality. So that's just an overview of what inequalities are. And now we're going to be going through how to actually solve linear and quadratic inequalities, and then how you can interpret these on a graph. So drawing a linear equation, a linear inequality is really similar to just drawing a normal linear equation, but instead you're just shading the areas that represent what the inequality means. So for example, a linear equation would just look something like y equals 2x plus 5. But if you had a linear equality, that would just change to y is less than 2x plus 5. So let's just say less than or equal to 2x plus 5 to start off with. So how you would draw that is you would just, if you had the y and x axes here, so you would just put the equation y equals 2x plus 5 normally on the on the graph. And one thing you need to note that, I'll put this on the side, if it's anything that has like less than or equal to or more than or equal to, that's always a solid line like this. But if it's just less than or more than, you would just plot a dotted line. So for this one, because it's less than or equal to, you just plot a solid line, and then we want to plot the graph y equals 2x plus 5. So let's say you have like this, then it would be something like this. It's not that straight, but yeah, that's fine. And then because it's less than or equal to, what you do is you just want to shade in the areas that are below the line, so anything underneath. So any of these values, would represent this equality. Y is less than or equal to 2x plus 5. If on the other hand it was y, let's say we had y is more than or equal to 2x plus 5, that would just be the areas above it. So the blue is less than or equal to, and then this, and then the green ones is just more than or equal to. So that's how you would represent a linear inequality. And similarly, and when we're solving equations and you have to graph it, you would just kind of graph it in a similar manner. But similarly, let's say you had a linear equation which was like x is less than 5, because there's no y, so you're not drawing an equation which has both y and x in it. You just draw the line x equals 5. So whenever you have like a linear equality, just think of what the linear equation would look like first, and then you can deal with the inequality later. So this one is just x is less than 5. You just plot what that line would look like. So we don't want a 5 there. So if we had let's say 5 was here, and then remember it's not a solid, it's not less than or equal to, it's just less than, so it's just a dotted line. So these are all the values when x is equal to 5, and then because it's less than, you would just shade in all the points that are less than 5, all the points that are to the left of the graph. If it was x more than 5, you do the opposite direction. So you draw a quadratic inequality in a really similar manner as you would draw a linear inequality. The only difference is you now think of the quadratic inequality as being a quadratic equation. So let's say you had a quadratic inequality which was x squared plus 2x is less than 0. So you just want to try and think of this equation as being a quadratic equation. So let's say it was x squared plus 2x is equal to 0. How would you solve that? Where would the roots be? So you just factorize it out and you would get x plus 2 equal to 0. So you'd get x equals 0 and x equals minus 2 is the points where it crosses the x-axis. So then you can just plot the graph normally. So it'll be over here, sorry. And then you know that because it's not less than or equal to, you want to draw a dotted line. And so the graph would just look like something like this. So if you don't remember how to draw quadratic graphs, and just go back to that video, just to make sure because you'll need this. And then because it's less than 0, you just look at the x-axis, and then you just shade in all the points that are less than 0. So it'd be all these points here. And if it was more than 0, it would be all the points above, all the points here above the x-axis. So yeah, that's just all you really need to know about graphing the different inequalities. So because it's less than 0, you can also think of this as being two equations. So let's say this was y is equal to x squared plus 2x, and this was y equals 0. So then where is the y equals 0? It's just the x-axis. That's how you just, that's why you know it's the ones below the x-axis. Let me just label that to make it a bit more clear. But yeah, that's all you need to know about drawing quadratic inequalities. Okay, so we have an example of a linear inequality here that we want to try and solve. So if you want to pause the video and try it out for yourselves and then come back to the solution. So we have 3 is less than or equal to 2p plus 5, which is less than or equal to 15. So the way you do this is you just split it up, and like you're dealing with 2 inequalities individually, and then you'll bring them both together again at the end. So you just solve them individually like how we did earlier. So for the first bit, we split it up, so we'd get 3 is less than or equal to 2p plus 5. We'd just solve that normally, so subtract 5 from both sides to have p on one side, so you'd get minus 2 is less than or equal to 2p, so then minus 1 is less than or equal to p. Then if we do the other side, we have 2p plus 5 is less than or equal to 15, so we have 2p is less than or equal to, if we subtract 5 from both sides, is less than or equal to 10. Then if we divide both sides by 2, you'd get p is less than or equal to 5. So then we want to try and write this just in one line, like in the format they have. So the way you do it is you just basically put them together. So we have minus 1 is less than or equal to p, but then p is also less than or equal to 5. So we would have here less than or equal to 5. And yeah, that's just the solution to the first question. Okay, so now moving on to actually solving a linear inequality. So let's say this was a question, it was x minus 3 is less than minus 1 plus 2x, and you're going to try and solve for the values of x. So what you have to do is you basically just rearrange it and just think about solving like a normal equation. So just think of this as being equals for now, and then you can always, so you just, think of it as being equals and you just rearrange it like a normal equation. So we want to put all the x's on one side and all the numbers on one side. So let's say we would add 1 to both sides, so you would get x plus x minus 2 is less than 2x. And then if you just want to subtract x from both sides, then you get minus 2 is less than x. Then so the solution would just be, if you just want to put the x on one side, then just use the inequality. It's like a x is more than minus 2. And that's just the solution to that linear inequality. So all you did was you just moved the you just rearranged the equation so that all the numbers were on one side and all the x's were on another side of the equation. Then if you want to graph this, all you do is, similar to before, you just think of the equation as being x equals to minus 2 and how that would look. You'd have a vertical line going along here. Then because it's just more than, it's not more than or equal to, it would just be a dotted line. It would just be like that. And then you want to think of all the values of x that are more than minus 2 is all the values on this side of the graph. So you just shade that in. So it just be all the values here. And that's just solving the equation. So one thing to note is when you're if you're just adding or subtracting things to both sides, you don't do anything to the side, like the direction or the way around the inequality sign is. You just leave that the same. However, if you're multiplying something, by like minus 1, then that would change the direction of the sign. So so if this works as if you're multiplying or dividing the size by any negative number. So if we have an example of, let's say we have 4 minus 3x is less than or equal to 16, and we just want to find the values of x that satisfy this inequality. So you just solve it like a normal one. So if we want to have the x's on one side, so we just want to bring the 4 into the other side, so you'd have minus 3x is less than or equal to, if you subtract 4 from both sides, it's equal to 12. And then you can divide, and then at this stage, if you want to divide everything by minus 3, this would flip the sign over because it's a negative number. So you just get x is more than or equal to minus 4. So yeah, just remember, if you're multiplying or dividing something by a negative number, you always flip the sign around. But anything else you're doing, the sign stays the same. So if you're multiplying something by a positive number, it stays the same. If you're adding or subtracting to both sides, this inequality sign stays the same. Only when you're multiplying or dividing something by a negative number, the sign switches. So yeah, let's go into an example of solving a linear inequality. Next. Okay, so now moving on to quadratic inequalities and solving them. So like what we were doing before is we just want all the x's to be on one side. So in this case, you would just subtract minus 36x onto one side from both sides. So you'd get 0 is less than or equal to, let me just do this in another colour to make it easier. So you'd get 0 is less than or equal to x squared minus 36x, and then it just looks like a normal quadratic equation that we want to solve. So we could just solve this on a side. So we have x squared minus 36x is equal to 0. So you just solve like a normal quadratic equation. So then we can factor out x. So we get x and we have x minus 36 is equal to 0. So then the two solutions you'd have is x equals 0, and then you'd have x equals 36. And then we want to draw this. In order to find out what values are actually more than or equal to 0, you have to draw the graph out, because this will help you see it more clearly. So if you draw the graph, and then you just want to plot it, so you'd have 0 here, you'd have 36. Then remember, because it's just x squared, it's just a happy frown. So remember from when we were drawing graphs out in the previous lesson. So because it's less than or equal to, you just draw like a normal graph like this. And then you want to find the values of x which are less than or equal to, which are more than or equal to 0. So which values of x have it when the graph is above the x-axis, if we label this. So this is just all the values that are here and here. All the values on these graphs are more than 0. So then this is 0. Then the values that you would have, all these values of x on the graph are less than 0. So you'd have x less than or equal to 0. Then all these values are more than 36. So you just have x is more than or equal to 36. So that's just how you would solve a quadratic inequality. And we want to be able to express these solutions using set notation. So for now, we're just saying and. There is a more mathematical way to put this. So I'll explain to you how to do this next. And it'll just make, they normally ask in some questions, express the solutions to this quadratic inequality using set notation. So you need to know that. But in general, whenever you're solving a quadratic inequality, move all the x's onto one side, move the whole equation to one side, so you have something that looks like a quadratic equation. You have something's equal to 0, and then just solve it like you would normally do to find those values of x. Draw the graph and plot it. And then if the equation is always more than equal to more than 0, it's just all the values of the graph that lie above the x-axis, and if it's less than or equal to 0, it's all the values of x that lie underneath.